Hello friends, welcome to my channel. This is Objective Mechanical Part 8, useful for BEL, State PSC, IAS, PSU, SSCJ and RRB also. Question is, refrigerant flow is controlled by A. Capillary tube, B. Condenser, C. Solenoid, D. Expansion valve. Answer is expansion valve controls flow of refrigerant. In capillary tube, it drops the pressure. In a reversed Carnot refrigeration cycle, the condenser and evaporator are at 27 degrees Celsius and minus 13 degrees Celsius respectively. The COP of this cycle is how much? Carnot refrigeration. This type of question I already discussed in ISRO question papers. It is a refrigerator, so work done on the system Q2. Here maximum temperature, minimum temperature. In this question, T max is 27 degrees Celsius. It's 300 Kelvin. T minimum is minus 13 degrees Celsius, so 260 Kelvin. COP of the refrigerator. It's Carnot refrigerator, so desired effect by work done. Refrigerator, so desired effect is minimum temperature. T minimum divided by work done is T max minus T minimum. So T minimum 260 divided by 300 minus 260, it will come 40. So 13 by 2 it's 6.5. COP of this cycle is 6.5. Answer is A. This type of question they are asking in GATE, IAS, PSU, BEL. This type of you will get. This is very important question. Usually secondary refrigerant in milk chilling unit is A. ammonia solution, B. sodium silicate, C. glycol, D. brine. Brine is our answer. For refrigerant in milk chilling unit, secondary refrigerant, we are using brine. Ammonia toxicity is there, that's why we are not using. Question is, in cooling tower, approach is the temperature difference between. First I will tell you some fundamentals for cooling towers. A cooling tower is specified by approach range and cooling efficiency, and the definitions are, for approach the definition is, it is the difference between the exit temperature of cooling water and the wet bulb temperature of the ambient air. So very important. So approach A equal to Tc2 minus Twb. Twb is the wet bulb temperature of the ambient air and Tc2 is the exit temperature of cooling water. And range is the difference in temperatures of incoming warm water Tc1 and exit cooled water Tc2. So R is Tc1, this is Tc1 minus Tc2. Then efficiency, cooling efficiency is actual cooling divided by maximum cooling possible. Actual cooling is Tc1 minus Tc2 divided by Tc1 minus TWB, wet bulb temperature of ambient air. So in this question they asked approach. So approach is Tc1 minus TWB. Approach is Tc2 minus TWB. This is the temperature difference which is unattainable. So Tc2 minus TWB. So hot water or Tc2 is cold water at outlet and wet bulb temperature. C is our answer. Hot water at inlet is Tc1, cold outlet water is Tc2. So this is range. Hot inlet water and wet bulb temperature Tc1 minus TWB. This is the maximum possible. Dry bulb temperature and wet bulb temperature D not. C is our answer. Question is, a hermetically sealed unit implies a compressor is sealed. In household refrigerator we are using this one, hermetically sealed reciprocating compressor. A compressor is sealed, B motor is sealed, C refrigerant cycle is sealed, both compressor and motor are sealed. D is our answer for hermetically sealed unit. Question is, chemical formula of Freon 12 or R12. For this type of questions I already made one separate video for refrigerants. You can check that one from a playlist, or if you want that one you comment, I will give the link. R12. So our formula is, we can write it as R012 012. Sequence is carbon, hydrogen, fluorine and chlorine. So R x minus 1, y plus 1, then Z. Then Q you have to calculate. Q is 2x plus 2 minus y plus z. X represents chlorine, Y for hydrogen and fluorine clone, Z. X represents carbon, Y represents hydrogen. Here Z represents fluorine, then Q represents chlorine. Then in this question R012, so carbon is x minus 1 equal to 0, so x is 1, carbon is 1. Next R012. Y plus 1 for hydrogen will calculate y plus 1 equal to 1. So y equal to 0. So H equal to 0. Then we will calculate for fluorine. So in this question Z equal to 2. So fluorine is 2. Carbon 1, hydrogen 0, fluorine 2. Then for Q value will get, I'll change the color. X, how much we get? 1. 2 into 1, 2 plus 2 minus y is 0 plus z is 2. So we will get Q equal to 4 minus 2, 2. So chlorine is 2. Chlorine value is, because Q represents chlorine. So here we will write 2. You can get the detailed explanation in that video. If you want that one, you comment, I will give the link. So carbon 1, H not available, CCl2, F2. This is our answer. A is our answer. One more thing is important here. R12 we are using in domestic refrigerator, used with reciprocating compressor. Small units we are using R12. Sometimes they are asking household refrigerator, which one you are using. So answer is R12. Its chemical formula is CCl2F2. How to calculate this one I already gave. Question is, dry compression is preferred due to a high volumetric efficiency, high mechanical efficiency, C, less chance of damage of the compressor, and all of the above. D is our answer. Dry compression is preferred due to high volumetric efficiency, high mechanical efficiency, less chance of damage of compressor. All are possible. Undercooling of refrigerant leads to undercooling of refrigerant. So it will come here. We are doing undercooling. So it will come 1, 2, 3, 3 dash and 4. Earlier it was here, this 4 dash. 1, 2, 3, 4. Due to undercooling, this portion increase. So refrigerating effect increases by 4 to 4 days. This portion refrigerating effect increases. So COP increases with undercooling. D is our answer. Refrigerating effect increases. COP we know, RE by watt term, RE increases, so COP increases. COP for refrigerator and heat pump are related as P of heat pump is COP of refrigerator plus 1. So from option C is our answer. One more thing important you should know: efficiency of heat engine with same temperature difference, it will come 1. Question is, if T1 and T2 are dry bulb temperature of air entering and leaving the coil, and T3 is the uppermost dew point temperature of cooling coil, then T1 bypass factor for sensible cooling of air is how much? So in this question, T1 and T2, here T1, then T2, then 3, T1, T2, T3 is apparatus dew point temperature. We know bypass factor, actual loss divided by ideal gain. So process is cooling from 1 to 2. This is actual. So loss is 2 to 3, T2 minus T3, or difference between 3 and 2, divided by ideal gain is maximum possible is T1 minus T3. So T2 minus T3 and T1 minus C is our answer. Bypass factor. During mixing of steams in case of air conditioning, the process is associated with throttling, no. Isobaric, no. Isochoric, no. Answer is adiabatic. Adiabatic mixing of steams in case of air conditioning. The humidity ratio is also expressed as where PS is the partial pressure of superheated vapor and P is the barometric pressure of the mixture. We know humidity ratio is or we can call it as specific humidity. Specific humidity is mass of vapor by mass of air. Mass of vapor divided by mass of air, or mv by ma, or we are writing it as 0.632 divided by vapor pressure is PS superheated vapor and total pressure is P minus PS. This is our answer. So B is our answer. 0.62, sorry, A is our answer. 0.62 PS by P minus PS. Zero 0.622 into PS by PA. Sometimes they will give PA. PA is partial pressure of air. Here in this question, P is given total pressure, so A is our answer. Thank you friends. Thank you for watching my video. Thank you.